This week, we're going to look at a topic that I see a lot of Python beginners struggle with, and that's copy versus deep copy. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for NSF Unidata. This week, I want to talk about a topic that I see a lot of beginners and even some not-so-beginners struggle with, and that's copies or deep copies of objects. And specifically, we're going to look at lists today because that's an easy thing to illustrate without writing a lot of code here. But the same idea applies to copying many other types of objects. Okay, so let's first start with the example that probably everyone has seen before or is familiar with. I've got a list A. I'm going to create a list B, set it equal to A. There's my list B. Now, if I take element 2 of my list B and set it to some value 9, we get the expected result. But if I look at A, you'll see that A has also been changed. So what happened here? Well, when we said B equals A, it created a variable B and just pointed it to that same object, A. We didn't say we needed a copy. We didn't say we needed anything else. It's really just an alias. So when we alter B, A is altered. When we alter A, B is altered because they're really the same thing. It's just two names for the same object that's being stored in memory. So this example has been seen quite a bit, but it does cause trouble for some people. Now let's go ahead and create A again. And this time I'm going to say B is equal to A dot copy. Now my list B is 1, 2, 3, 4. If I do the same operation, setting the second element of B to 9, B is what we expect, and A remains unchanged. This is because copy has copied those elements and created a new object in memory, B, that is independent from the object A in memory. So you may think we're all set, and we can end the video now. But let's take a look at something a little more complicated. And remember, in Python, everything is really just an object. Lists are objects, strings are objects, arrays are objects. So when I say object, I could be referring to anything, or list, I could be referring to any object. I'm going to set a list A to be 1, 2, B to equal 3, 4, and I'm going to create a list C, which is A and B. So there's my list. It is a list of lists, or a nested list. So I'm going to create a copy called D, and I'm going to go ahead and copy this onto my clipboard to save us some typing. And as you might expect, if I change an element of our list C, D is also changed. And that's not surprising to anybody now, because we know that D and C are just referring to the same object in memory. So I hear you say use copy. All right, so let's create our lists again. D is equal to C.copy. Okay, there's my list D. I'm going to set my element again. There's D. And there's C. And it still has the behavior. It looks like they're both pointing to the same thing. But I used copy. So what's happening here? Well, what's happening is that copy, when it creates the copy, will just copy over references to any objects that are in what we're copying. So in this case, I have a list of lists. So it looks at the first element of my list that I'm copying, which is C, and it says, oh, here's a list. It's just an object, and I can copy that reference. And then it goes to the next element. Oh, this is just a list. I can copy that reference. So it looks like we didn't make a copy at all, even though these are two independent things in memory. Really, I'm just copying the references to those sub-elements or those nested elements. So for example, what would happen if I set D of 1 to be 7 and 8? So there's D, there's C. C now looks unchanged because I changed the entirety of that object in D. Okay, what if I wanted to do what I thought I was doing the first time? So let's create our lists again. I'm going to import the copy module. D is going to be copy.deepcopy C. There's D, there's C. D, 0, 1 is equal to 5. There's C, there's D. So now that gives us the behavior we might expect. So I hear you saying, why do we have these different behaviors? Well, there are a lot of times where we may want to not copy every single internal item as a copy. Maybe we want to share a class. And we can do that with a simple copy where the two instances of that copy are going to point to the same instance of the class. But sometimes we need a deep copy, which goes through and actually creates a copy of every object inside the object that we're looking at. So in this case, the objects are nested lists because that makes it easy to illustrate. But again, it could be any object containing objects. You can see where a lot of bugs can come from this. You're making a copy of something and then you're going to modify it. And this is my modified data or my corrected data or my QC'd data. And then you try to go back and compare it to raw and it says there are no differences. Well, it's because you didn't use the appropriate copy or deep copy method, and Python's trying to do you a favor. Now, there are a few instances where deep copy could go wrong, and Python does a good job of protecting you. For example, if you were deep copying something that contained the thing that it was copying, you could get a recursive copy that goes on forever. And Python does keep a list of what's already been copied, and if something has been copied once, it will not copy it again. And there are a few other edge cases where maybe you want to share data between copies, so you don't want to hold all of that in memory. And you can override things as the user to point to a specific shared instance of an object. But in general, just not using copy or deep copy results in the most bugs that I've seen. I hope that you found this useful, and I'll see you on next week's MetPy Monday.